Hello everyone. In this video, we are going to discuss how to write a program to calculate the sequence component of a line voltage when the given unbalanced phase voltages. Unbalanced phase voltages are the VR, VY, and VB, three phase voltages, and the sequence components are positive sequence, negative sequence, and zero sequence. These three sequences are separate for R phase, Y phase, and B phase. Let us start with R phase sequence component calculation, and here we are having the calculation part. V or not, where 0 represents the zero sequence, R represents the phase R phase sequence voltage. Okay, similarly VR1 means positive sequence voltage and VR2 is the negative sequence voltage. The zero sequence voltage for R phase is given by 1 by 3 times VR plus VY plus VB. Okay, and for positive sequence R phase voltage, it is given by 1 by 3 times VR plus A times VY plus A square times VB. Similarly, the negative sequence R phase voltage is given by 1 by 3 times VR plus A square times VY plus A times VB. This is for R phase. Similarly, for Y phase and B phase, and the Y phase zero sequence is very much equal to R phase zero sequence. Y phase positive sequence is A square times R phase positive sequence, and Y phase negative sequence is A times negative sequence of the R phase. Similarly, for B phase, zero sequence is equal to R phase zero sequence. B phase positive sequence is equal to A times positive sequence of the R phase, and negative sequence of the B phase is A square times negative sequence of the R phase. And let us try to write the program specifically for R phase now. Here, to write a program for R phase sequence voltages, we need phase voltage VR, VY, and VB. Along with, we need the unknown parameter A. The component A is a constant, and now we are going to check it in the program. Let us start the program with CLC, where CLC represents the clear memory command, and clear all is used to remove the items from the workspace, freeing up the system memory. And the unknown parameters are R phase unbalanced voltage, Y phase, and B phase abnormal voltage. Sorry, not unbalanced, the abnormal voltages. Using the input command, we can fetch the R phase abnormal voltage and Y phase and B phase abnormal voltages. And the value of A is constant, and it is given by minus 0.5 plus J 0.866. Using the formula from the above calculation, we can calculate the zero sequence R phase voltage as 1 by 3 times VR plus VY plus VB. Similarly, for positive sequence R phase voltage is given by 1 by 3 times VR plus A times VY plus A square times VB. Similarly, the negative sequence R phase voltage is 1 by 3 times VR plus A square times VY plus A times VB. Let us copy this program and try to run it in the MATLAB so that whatever we have written is correct or not. Let us check it. And here I have already copied the program. We are starting with CLC, clear all, R phase voltage, Y phase voltage, and B phase voltage are taken from input command, and the value of A is constant, and we have already written. And the sequence voltage calculation part, we have copied it here. Let us run this program. Enter the R phase voltage. To enter the R phase voltage, we need some values. So let us consider a problem here where the voltage in a three-phase unbalanced system, VR is 3 plus J0. Let us take this 3 plus 0J. Oh, it is taken. The J value, we should keep it a small letter. 3 plus 0j. Yeah, now it is taking. Along with the y phase is minus 1.5 minus j 2.598. Minus 1.5 minus 2.598 j, and the B phase voltage in this problem it is 0. Let us type it as 0. So now we got the value of V2, V1 and V0. Okay, the value of V0 is 0.5 minus 0.866i. V1 is 2, only a real part value has been fetched out, and V2 is 0.5 plus 0.866i. Okay, we don't have any errors here, and this is for R phase. Okay, if you want the same for Y phase and B phase, we can change the program as Vy0, Vy1, Vy2. Similarly, we can write it for Vb0, Vb1 and Vb2. And from the program and whatever we have calculated here we are having, see, Vy0 is Vr1, Vr0. We can directly take it from here, and the same we can copy it, and for Vb0 also it is same. And for Vy1, what was that? A square into Vr1. Yeah, A square into Vr0, and here it is A times Vr0. And Vb2, Vb1 is A times Vr0, and Vb2 is A square times Vr0, right? A square times, sorry, Vr1 and Vr2, sorry, we just marked it as Vr1, Vr2, Vr1, and here it is Vr2. And after saving, if you run the program again, yeah, we are getting incorrect use of equals. Complete equal. Use and line 7. Okay, and we have taken Vr0 here. That has been a mistake. Now, if you run this program again, enter the R phase voltage from the program. If you take it, the R phase voltage is 3 plus J0. Let us type it as 3 plus 0j, yeah, small j. And Y phase voltage is minus 1.5 minus 1.5 minus 2.598 j, right? 2.598, yeah. Okay. If you enter, it is asking for B phase voltage and it is 0. Now we got, yeah, here we can see Vr0, we have got Vr1, we got it, Vr2 also. Similarly, Vy0, negative, zero sequence of Y phase, Vy1 positive sequence of Y phase, Vy2 it is negative sequence of Y phase, Vb0 zero sequence of B phase, VB1 positive sequence of B phase, and lastly VB2 negative sequence of B phase. Hope you people learned something, and if you people have any doubts, please do comment below. We'll be connected. Thank you.